Hello and welcome to the Chapter 1 podcast on Section 3. So today we're going to talk a little bit about properties of matter. Properties of matter, again, something we talked a little bit about in the first section. There are physical properties. These are properties that can be measured without changing the identity, the composition of the substance. So in other words, these are changes where the compound doesn't break down into other things or into its elemental components. Chemical properties, though, the substances actually become something else. Okay, so for instance, a physical property would be like boiling point, where, for instance, water goes from liquid to gaseous form, but it's still H2O. But a chemical property would be, for instance, for like a hydrocarbon, its ability to combust, which causes the compound to become something else. It actually chemically reacts and becomes new substances. Sorry, I got an email there. There are intensive properties. These are properties that do not depend on the amount of the substance. So things like temperature, boiling point, melting point, density, these are things that are intensive properties. It doesn't matter how much of it you actually have. Extensive properties do depend upon how much of the substance you have. So mass and volume and things would be important for those and would change extensively. There are things also known as physical and chemical changes. Again, some review stuff. These are change in physical appearances, but not in composition. Basically, any change of state is a physical change. There are chemical changes as well. These are transformations of a substance from one form to another. And I have a little picture here of Ira Remsen. He's a good-looking man, right, with his mutton chops there. And he did a little experiment with a penny that I've kind of cartooned on the bottom. I'm going to read his little story that pertains to this. It's kind of funny, and it's also he kind of explains how he got interested in chemistry. I read to my kids all the time, so it's like I'm reading to them. While reading a textbook of chemistry, I came upon the statement, nitric acid acts upon copper. I was getting tired of reading such absurd stuff, and I was determined to see what this meant. Copper was more or less familiar to me, for copper cents were then in use. I had seen a bottle marked nitric acid on a table in the doctor's office where I was then doing time. I did not know its peculiarities, but the spirit of adventure was upon me. Having nitric acid and copper, I had only to learn what the words act upon meant. The statement, nitric acid acts upon copper, would be more than just mere words. All was still. In the interest of knowledge, I was even willing to sacrifice one of the few copper cents then in my possession. You have to remember back then, copper cents was actually a lot of money. It's not like now where pennies don't matter as much. I put one of them on the table, opened a bottle marked nitric acid, and poured some of the liquid on the copper and prepared to make an observation. But what was this wonderful thing which I had beheld? The scent was already changed, and it was no small change either. A green-blue liquid foamed, and fumed over the scent and all over the table. The air in the neighborhood of the performance became colored dark red. A great colored cloud arose. This was disagreeable and suffocating. How could I stop this? I tried to get rid of the objectionable mess by picking it up and throwing it out the window. I learned another fact. Nitric acid not only acts upon copper, but it acts upon fingers. This pain led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid acts upon trousers. Taking everything into consideration, that was the most impressive experiment and relatively probably the most costly experiment I have ever performed. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about this was to see its results, to experiment, to work in the laboratory. And, besides these lectures and things that we're doing with these podcasts, we'll also be doing a lot of problems and some worksheets, but we'll also be doing a lot of, as many hands-on activities and experiments that we can possibly do, because that, while it was a painful, luckily he didn't kill himself type of moment for him, it was, for him, the beginning of his journey into chemistry. And that's something that I hope happens for you guys. Not necessarily in chemistry, but, whatever it is you find interesting in life. But my job, besides teaching you teaching you about chemistry and preparing you for the AP exam, I also consider it my job to kind of give you opportunities to have moments like this in your life. And who knows, it may change the way you view chemistry and change what you're interested in. So back to the lecture here, we have a separation of mixtures. Mixtures can always be separated. What you have to do is you have to take advantage of the differences in some of the physical properties of the mixture. There are a few different generalized ways we can separate mixtures. One is a process known as filtration. Basically, you separate a solid from a liquid. You have like a piece of filter paper, and you have a porous medium, and basically the liquid goes through the paper and the solid stays behind. We also have a process known as distillation. This is a way to measure, to separate two liquids, and it's based upon differences in boiling point. So this first figure here that I'm circling with my arrow, this represents filtration. This second little figure here represents distillation. What ends up happening is you heat, if you have two liquids mixed together, they're going to have different boiling points. So the one with the lowest boiling point will actually boil off first. Where's my map? Oh, there it is. And what ends up happening is the gas comes up to here, and because this is plugged, it follows through this what we call condenser tube. The condensing tube actually has cold water flowing through the outside, and the gas is in a little inner pipe flowing through. The cold water running through actually condenses the gas back into a liquid, and it collects in this little recovery flask. Then you stop once the temperature, once you separate your first liquid. Another way to do this is a process known as chromatography. So this is separation on a solid medium. Almost all of you probably have done chromatography in your biology classes. The old separation of chlorophyll experiment is the famous one. Sometimes you do marking pens. Some people do M&Ms. We'll do a quick chromatography experiment in here as well. And basically, the separation is based upon attraction to the chromatography paper. And I believe that's it. So I'll see you next time.